All right, I went in and made myself an account. Didn't have to pay anything. You have to if you want to do extra things. But I'm just gonna go in and show this and do a calculation or so off of this. Let's say we have a 20-foot beam, well, not 202, but 20 foot. We're going to add a support, a pin support at location 0. We're going to add another support on the far end, a roller support at, I think I said this thing was 20 foot long. So a simple case like that. And then I'm going to add a distributed load. Starts at 0, ends at 10. I'll say it's 100 pounds a foot, going to 100 pounds a foot, and I'll add it. So there's my case. Below what you'll see is the supports, the distributed load. You can add a point load. Let's say you add a point load of, let's say 15 at, I don't know, 500. Add it. So what you'll see is it gets added down here. There's nothing else to do. I could add moments, another distributed load, but I'm not going to do that. In this one, I think you go here, you push the solve. Now, I don't know what that is, certificate level 1. So, I think if you go in here and do that, you're going to have to pay. But if you want to pay, it's up to you. Here, you will see a shear force diagram. Now, you're not required in this course to know that, but in mechanics and materials you will. And here's a bending moment diagram. There's a deflection and some stresses. You've got to pay for that. But let's take a look at just one particular case. Let's take a look at, it doesn't look like I can, oh, maybe I can do this. Let's say 8 foot. Okay, I have to pay to look at the actual value there, but let's just look right in here at 11 feet. You can see a shear force here at 11 feet. Okay, you can get an idea of about what that is. Let's solve this problem. First of all, he gives you the endpoint reactions, the 875 and the 625. Let's go off and do this one. So you can see how this is done. And instead of me drawing it, how about I do this? Okay. I was unsure that I could do that. Okay. New. And I'll just drop it right in here. So first thing let's do, let's verify this and that. So first, this is occupied over 10 feet, that is. So that means 100 times 10 is 1,000 pounds. This is almost like stacking a set of bricks from here to here of equal distribution. So it equivalently looks like it's about 1,000 pounds right there. Let's check that. So that would be at 5 foot. Maybe we'll check that in a minute. I don't want, let's see, unless I can save my work here. Let's see if I can. file. Let's see. Save as. Can I save it as? Let's see. Enter your file name. Say PO1. Let's see. Your file was successfully saved. Let's see if I can open PO1. So it looks like I can open this file. Okay. Alright, now that I've got that open, here's what I'm going to do. I'm going to take this distributed load. I'm going to delete it. I'm going to add a point load that I believe was at 5 foot and was at 1,000 pounds. If I add it and then I solve this thing, there's something interesting that happens as far as the reaction loads. Take a look here. We have 875 on the left and we have 625 on the right. Was that what we ended up with? 875 on the left, 625 on the right. So as far as the reaction goes, this 1,000 pounds at 5 foot over is exactly the same as a distributed load. Does the shear diagram look the same? Let's take a look. Okay, the shear diagram does not look the same. Let's save this one. Save as. I called that PO1, so I guess I'll call this one PO2. Okay, let's look at, okay, here's the shear diagram on PO2. Let's grab, open. Okay, here's my PO1. Shear diagram look the same? The answer to that is no. The reaction loads are the same. Shear diagram not the same, but let's let it load. No, not the same. Let's take a quick look at our two problems. Let's go ahead and start with the one we had before, PO0. We look at this, we do a solve. We're going to compare so what we're going to do, go back over to, let's just ask a question here. We're going to paste it right here. Then we're going to go back over. We're going to go down. Look at the shear diagram of the same one. Drop it down underneath it. It may not line up with it exactly, but it's close. And to make this discussion complete, we're going to go on down, get the moment diagram, the bending moment diagram. We're going to explain these, but we're going to ask the question, why are they different? I want to snip the next one for the bending moment diagram. Go in, drop it under there as well. Then what I'm going to do, go back to the top. I'm going to, if it will allow me, it will if I'm here, I will slide to the right and I will drop the others there. Here's what I mean. We go back to File, PO2, open it, solve it, going to snip the information from the free body diagram, drop it right here. Maybe move it up a bit. And I'm going to go back. Look at the shear diagram, and let's compare those two. And we're going to compare them in detail. It's maybe have some educational purpose in doing this, like explaining what these are. Trying to make it about the same width here. Somehow these got joined together. Uh-oh. Trying to make the links line up as best I can. Oh.